We are going to continue our discussion about exponential growth and decay, but we're actually going to look at some like applications to like what it looks like beyond the math class. Okay, all fours, please. Okay. Now, exponential growth. We know this happens when we have an amount that is increasing by the same factor. Allison, did I get your question answered? Yes, you asked what page. Okay. When I say the word factor, I am implying what operation? Okay, now, when we have exponential decay, we have an amount that is decreasing by the same factor. Once again, factor means we are multiplying. Okay, so we kind of talked about, okay, if we're multiplying by a number bigger than 1 every time, we have exponential growth. But if we're multiplying by a number less than 1, like 1/2 times 1/2 times 1/2 times 1/2, then we are decaying, okay? We're getting smaller. Okay. Now, what we're going to talk about are scenarios in which we have a rate of increase or a rate of decrease. We're going to do interest tomorrow. Yeah. Okay, so we're going to start out with an amount. Then we're going to multiply over and over and over and over and over by a number that's bigger than 1. Specifically, 1 plus our rate. So if our rate is 5%, that inside number is 1.05. If our rate is 15%, that middle number is 1.15. Okay, we're multiplying by a number bigger than 1. What do you think T stands for? Yes. Okay, so then exponential decay, how do you think it's going to look different? No? I'll give you a hint. It's something in here. 1 minus R. We need a number smaller than 1. We need a number smaller than 1. All right. So tomorrow, those of you who are interested, tomorrow is when we're going to talk about compound interest. Okay, I think that's what Ian was asking about. But right now we're going to stick with these two. So when we look at this equation, A is our initial amount. So if we start out with $1,000, that's A. That's our initial amount. Okay. Our rate of growth in decimal form goes right here. T is time. Okay. This 1 plus R, this is what we call our growth factor. It's that number that's more than 1 that we're multiplying by over and over and over and over. Once we do all that, Y is giving us our final amount. Okay. All right. So we're going to do a couple examples. Okay. LVMS has 750 students. That's a rough estimate. Okay. If the student population increases by 2% each year, then what is the population in 5 years? So if you want to abbreviate that a little bit, that's fine, but we have 750 students. We're increasing by 2% each year. And I want to know how many students we have in 5 years. What? 825. No. We haven't even talked about what these numbers mean yet. Okay. No.
2% of 750.
Can you just stop right now? 750. What letter is that? What variable? Nope. A. 5 years. What letter is that? T. Is R 2?
Huh? No, it's 2%.
So R is? A. So what we're doing is we are taking y equals A times 1 plus R to the 5th power. Could you guys look over here, please? Back here at my calculator poster. This is what you can do with the nice calculators that we have. Type in 1.02. Everybody type it in. No, you're supposed to pass those back. I literally only said 1.02. Now, instead of saying 1.02 times 1.02 5 times, what I want you to do is I want you to put the caret and then the 5. This caret right here.
I got 1.
Just stop. Brooke, stop. I want you to do 1.02 caret. That means raised to the 5th power.
Oh,
It equals, then you can multiply it by 750. Syntax error means you didn't type it in right.
How do I go back? 828.
what's the answer?
828.
See, I was close.
Okay, so go ahead and stop talking. Stop talking. Does everybody have written down the formula in blue? In our calculator. Look up here. We're going to type in Ellery. We're going to type in 1.02 to the 5th. So 1.02 caret 5. That gives you the exponent of 5. Hit enter. Then with that number, you can multiply by 750. I wish this was a real calculator. Ellery, did you get it? What? I don't know what you said, Ellery. Yes or no?
Yes.
829.
I forgot 825.
Okay. So this, we'll just say times.
Writing the number in.
Okay, so here's the deal. Here's something that's really nice about these calculators. When you said 1.02 caret 5, enter, and you got 1.1 blah, 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 blah. You don't have to type that in again. You can just say times 750 and it'll times it for you. Okay? You don't have to type it in again. Stop being loud. Okay, so let's try another one. The first music festival had 150,000 in attendance. Attendance increases 8% each year. Well, attendance for the 5th year.
We do 1.08. I got 1.08.
Okay, so do you agree 1.08? Okay. We have 1.08 and we have 150,000. But what exponent do we have?
Aren't you 4?
How did you get 4?
It's the attendance for the 5th year.
Because it's attendance for the 5th year, which would be in 4 years.
Wait, what? So is it 5 or 4?
It's 4.
Oh, I did it wrong. Harry, let's
Tell him,
go,
hey.
though. I got 24.
That's a 4. Because it's asking for the 5th year.
I got 2.
So that would be in 4 years.
No, it's actually 240. I said 240.
You should have 204,073. Can we have 0.3 of a person? No.
What if you just like take their arm off and then one of the legs?
What if it's like a-
That'd be like.
What if it's just like a?
I didn't measure.
All right, let's try a decay problem. Next page. You're not even what? Hey, Connor, it's right here. It's right here. We're gonna go to the next page, and I want you to take a look at the decay model. Notice how everything is the same except 1 minus R. Connor, you give me a thumbs up when you're good, okay? You're good? Okay. All right, here we go. A car is valued at 21,500. It loses 12% of its value each year. I want to know the value in 10 years. Okay, is this like a real thing? Like, do cars depreciate?
Yeah, not.
They sure do.
Well, like some of the good ones, they go up.
It could be an investment piece.
Like what?
Like the Porsche GT3.
Okay.
The Porsche GT3. The Porsche GT3.
Let me get the tip.
Okay.
Just
For the cars that we drive. What?
That's 12.
That is 12%. Okay, so when we set this up, I'll give you a little bit of time to I know some of you are still writing.
I got it. Are we, or do we put cents too?
We have cents marked, put cents.
Okay, no, this would be 10. So our initial value is the 21. 21.5. And we have 1 minus our rate. So what number is our base?
0.88.
Wait, so would it be to the 10?
Yep,
In 10 years?
in 10 years. Yep. Okay, so in your calculator, you have an answer? Okay, hold on. In your calculator, you're putting 0.88 to the 10th. And with that number in all of its long decimal glory, you're multiplying it by 21,500. Okay, so DJ, what do you have?
You forgot the
Yeah,
change.
because you had to round up.
Change now. Yeah, buddy.
Exactly, you had to round up.
So 5,987.77. What?
87.
That's not what you got in your calculator? Okay, so if you put in 0.88 to the 10th, you should get like 0.2785, blah, 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 blah. Is that what you got, Brooks?
I got 13,000.
Buddy, what is, how did you, what?
So Brooks, could you please put in 0.88 to the 10th and hit equals? What'd you get, Brooks? Okay, so now hit the multiply button and type in 21500.
I got 5,988.
But there's like change.
But it's money, so we can do the decimal. Okay, all right, now. On the page next door, I would like you to, in number 1, set up the equation as A, and then plug in a number for B. I want to see what you get.
Wait, which one?
On the next page, number 1. You guys. Like, it's literally on the next page.
How many years does that have to be? 4 years?
What?
How many years does that have to be? Until,
So here, yours is gonna be T.
yeah, well.
Here, how many years is it from 2005 to 2000? Rabbits in Polygon Park.
20 years?
Oh, how did I miss your school?
What'd you get? What'd you get? I got 806. And a chip. Okay, you got this, but I got baby. I would say 806 and down. Alright, I got 16,000. Okay, so
Oh
we're
my. Okay, so we're having a little struggle here. You guys. Oh my.
you gotta get overflow.
Okay. For your equation, what is A? 100. And if it's 11%, are we growing or decaying? So 1.11 to the T, right? Okay, you guys, if we begin in 2005, how many years to 2000? Good. 20 is our time. 20.
NBR.
How many rabbits?
806.
806. How many of you put 2025 in for T? That's why you got overflow error.
I just don't know how to do it.
What don't you know how to do, Brooks?
So how'd you get 1.11 like inside number?
So we're growing. Okay, here's the deal. Brooks is asking a question and I can't even hear myself think. 11% is 0.11, right? And we add it to 1. Is that okay? Are you okay with putting this into your calculator? You guess. Okay. Right now, this is what I'm going to ask you to do. I'm going to give you 5 minutes, maybe less. You are going to decide if we have exponential growth, decay, or neither for 2 through 5. Then I want you to figure out if we have exponential growth or decay and what the rate of growth or decay is. So 2 through 5 is it growth, decay, or neither? 6 through 8, figure out if it's growth or decay and what the rate is. I'll give you maybe 3 minutes. 3 minutes sounds better. You can work with your elbow partner. Hey, you're actually working on math now. I don't care.
How do you get Randy? Press I. No. I got Randy.
Oh,
Random.
Rand. What about Rand? I guess I'm just gonna ask. What about Rand? Yeah, exactly. Being multiplied by Rand. Random, random. Yeah. Connor. Third one. Just follow. What's the point? It doesn't matter what the time is. I want to know if it's growth or decay. Oh, we're doing 6, 7, and 8 too.
All right. I don't know what you guys got fed for lunch, but whoa. Whoa. All right. Kyron, is number 2 exponential growth or decay? What are we multiplying by every time?
1.5.
What?
We're multiplying by 1.5 to get from one to the next. Okay, Brooks, what do you think about number 3? What are we multiplying by every time? Hey, actually, it means the same thing. Stop being.
I already started that.
Okay, and you finished it. Okay, Drew, number 4. Okay, what is it? All right, we are subtracting by 10, so this is a linear function. You can't wait 7 minutes. Yeah. Okay, Eli, what about number 5? What are we multiplying by? 2.5. We're multiplying by each time. All right, now, when we have an equation in number 6, Carly, do we have exponential growth or decay? We have decay. Virgil, how do we know that this is decay? This number is less than 1. Harry, specifically, what is our rate of decay? 5%. This is 0.05 under 1, so 5%. Okay. All right, Kaylee, growth or decay for number 7? Zayden, how does she know it's growth? Because it's like above 1. Okay. DJ, what is our rate of growth? Is 8%. Good. People panicked about number 8. What is 3/4 the same as? 0.75. So do we have growth or decay? And what is our rate? 25%. Okay, here's the deal. I am going to give you a book assignment that I will get posted right now. I will not forget. Okay. Tomorrow we are going to look at compound interest. So you know what we can do. We can get the first couple problems of our homework started. So in your notebooks, because we have 5 minutes, that's plenty of time. Is this 6.4? Look, you guys, this is the homework answers.
Oh, come on.
Just let that open.
Who has their gold sheet handy?
It's like 35.
319. No, page 319. We're 6.4. So I know that you need to do 33. Whoops. Try that again. Here. How about you do 33 through 38 right now? That would be perfect. For right now, do 33 through 38.
I think it's 33 to 48.